Up. Why do you say up? Because we have a positive 3 here. Remember, we look at the A term, and if it's positive, our parabola opens up. So all we're going to do is we're just sketching right now. So we're just going to sketch a parabola that opens upwards. And we want to try and make it symmetrical as much as we can. Okay, so I'm going to try to make it as symmetrical as I can. We haven't looked at how wide the parabolas are or how skinny they are, so right now we're just sketching it. Okay.
For y equals 1, how do you find 1 is symmetry? You just use your answer you get for y all the time.
You use your answer. From the vertex, the line of symmetry is the x value.
Okay.
So it's y equals the x value. Because it's a vertical line, right? So y is, or x is always the same. Okay, so if I sketch the parabola, do I have a minimum or a maximum value? Let's look at it. My minimum or maximum value is always going to be the vertex. Is my vertex at the lowest point on the parabola or at the highest point? It's at the lowest, so we have a minimum value. So we have a min value, and it's at what point? At 1, 1. And that's all we have to do. So it sounded like a lot of work when we were taking the notes, right? But it's really not that much. Okay, so I would also label this min value on the graph. At 1, 1. Your vertex is always going to be either the min or the max. Okay? Alright, so example 2. Y equals negative 3/4 x squared minus 4x minus 1. The first thing I want to find is the vertex. So I'm going to label it again. And to find my vertex, I need to first find the x value. So x equals, and we're going to use that same equation that we used in the first one, negative b over 2a. What's my b in this problem? Negative 4. b is negative 4. So I'm going to have negative 4 over 2 times a is what? Negative 3 over 4. So 2 times negative 3 over 4. Negative 4 gives me positive 4. And 2 times negative 3 over 4, what does that give me? 2 goes into 2 once, 2 goes into 4 twice, so I'm going to get a negative 3 over 2 in my denominator. And if I have a fraction in the denominator, does anybody remember what happens? Let's do it off to the side. So I have 4 over negative 3 over 2. Okay. When I'm dividing fractions, let's rewrite it as 4 divided by negative 3 over 2. So we can see it a little bit easier. And dividing fractions is really multiplying by the reciprocal. So this is the same as 4 times what? Negative 2 over 3. So 4 times negative 2 over 3, what does that give me? Negative 8 over 3. So my x value of the vertex is going to be negative 8 over 3. Okay, let's find the y value. So to find the y value, we plug x back into our original equation. So negative 3 over 4 times negative 8 over 3 squared. minus 4 times negative 8 over 3 minus 1 okay, that equals negative 3 over 4 times negative 8 over 3 squared. Okay, remember our rules of exponents. We can just distribute that squared in there. So what would negative 8 squared give me? Positive 64 over 3 squared, 9. Minus 4 times negative 8 over 3, 30. So that's going to be negative 4 times negative 8 actually gives me a positive 32 over 3 minus 1. Okay, let's keep going. Equals. Let's multiply these guys. First of all, does this reduce at all? 3 goes into 3 how many times? Once. 3 goes into 9? 3 times. What about 4 and 64? 4 goes into 4 once, and 4 goes into 64? 16. So we have negative, remember that negative out here, negative 16 over 3 plus 32 over 3 minus 1. Can we change 1 so that it has the same denominator? What is the same as minus 1 if we want a denominator of 3? 3 over 3, right? So I changed it so we all have the same denominator. And now let's just add and subtract. Negative 16 plus 32. 16 over 3 minus 3 over 3, which gives you 13 over 3. So what is my vertex? The x value was negative 8 over 3. The y value was positive 13 over 3. So that's my vertex. I'm going to put a box around it so I don't lose it. Okay, where is negative 8 over 3? That's about 2 2/3. So negative 2, 1, 2, and 2/3 is like somewhere in the middle. And 13 over 3, 3 goes into 13 4 times, 4 and 1/3. 1, 2, 3, 4, and 1/3. So we're somewhere right here. In the middle somewhere. Okay. So I'm going to label that vertex and put the point. Negative 8 over 3, positive 13 over 3. And then we want to find the line of symmetry. Line of symmetry. My line of symmetry is going to be y equals what? Y equals the x value. What's the x value? Negative 8 over 3. So let's draw that. It's going to be a vertical line because right now we're only dealing with up and down parabolas. We haven't done side to side yet. So I'm going to label that also LOS. X equals negative 8 over 3. Okay, now we want to sketch the parabola. Sketching my parabola. Is it going to go open upwards or downwards? Downwards, because A is negative, so let's sketch it going down. So we're going to try and make it as symmetrical as possible through the vertex. And we do, guys, want our parabolas to be curved at the vertex. You don't want them to be look like V's. So we do want them to be U-shaped, okay? So try to make it as smooth as possible when you're sketching. And in this case, since we are going downwards, do I have a maximum value or a minimum value? A max, right? So I'm going to have my max value. So my max value is at the vertex, which is negative 8 over 3, 13 over 3. So example number 3. Example number 3, 4, and 5, all we want to do is find the x-intercepts of each parabola. Okay, so this is stuff we already know how to do, right? Alright, so let's do it really, really quickly. Because then we're going to tie it all into our graphing. Okay. So to find the x-intercepts of each parabola, y equals x minus 8 times x plus 2. What do I need to do? If I'm looking for the x-intercepts, I'm looking where the graph crosses at y equals. What is y supposed to equal when we cross the x-axis? Okay, if we're crossing the x-axis, y equals what? Zero. Thank you. So in order to solve example number 3, we need to set y equal to 0. So let's do it. So we have 0 equals x minus 8 times x plus 2. Okay, and this is nice because it's already factored for me. So what am I going to do? Set each one equal to 0. So we have x minus 8 equals 0. We add 8 to both sides. So x equals 8. And x plus 2 equals 0. So x equals negative 2. So those are our two x-intercepts. So how could we use this to help us sketch our graph more accurately? Any ideas? Well, let's look at, well, kind of. Let's look at, go back to example 2 really quick. Here we have a parabola and they cross the x-axis. So how could we make our graph more accurate? Well, our line of symmetry is telling us down the middle that each side is going to be symmetrical. We have the vertex. Now, I crossed the x-axis here, but I don't know if those points are correct, right? Yeah. How could I make my graph more accurate then? I can find the x-intercepts, right? If I found the x-intercepts, I would have some points, and I could draw a parabola through those points, right? Okay, so that's what we're using this for. That's what we're heading towards. We're still going to, we're going to practice a little bit more. So will you find the x-intercepts for examples 4 and 5? Okay, so example 4 is pretty easy for us because we already have everything factored. The only thing we have to do is set y equal to 0. 5 times x minus 1 times x plus 3. Okay. And then how many factors do I have in this example? I have 3 factors. 5, x minus 1, and x plus 3. Which of these do I have to set equal to 0? The parentheses. How come I don't set 5 equal to 0? Because it's not possible. We could write it out if we want, but 5 doesn't equal 0. So that's not a possibility for us. So we have x minus 1 equals 0. Add 1 to both sides, and we get x equals 1. and x plus 3 equals 0. We subtract 3 from both sides, and we get x equals negative